Hi, welcome. So we're going to jump in, and today we'll be talking about units and measurements. And this is something you probably feel like you're really familiar with. You've been doing it for years, hopefully, in different classes. Um, but what I want you to think about is if I asked you to measure something, the first question you might ask is, what's this, right? What am I supposed to be measuring? So when we're talking about this example, what we're measuring is length. And really the way to describe that is distance, right? The distance between 2 points, the point of this pin to the point of this pin, how far apart are they? How separated are they? And if we ask both of these people, what is this length? You might get different answers. So yellow says, I got 39. Blue says, I have 15. So your first question should be what? Like, how is that possible? How can one person say the exact same object is 39 and the other person say it's 15? So we have to be careful. And this is when we go throughout the year, we're going to make sure we're being very particular in how we say things. So if this person says, I have one, and this person says, I have one, great. The problem is when you're talking about just numbers, a number with no unit doesn't mean anything. So if I ask you one of what I'm really asking you is what's the unit, right? And we just said we're measuring length. So they're like, I have one length. And the other person's like, I have one length too. So you can tell this isn't really useful in giving you information to make a decision with, right? So what we want to do is ask them, show me what does one length look like. And when you ask yellow, they show you this thing. And when you ask blue, they show you this. And you can see there's a difference. What the one thinks is one, the other one doesn't think is one. So we're not talking the same language here. So if you dig in a little deeper, what you'll come to find is that yellow is using a meter stick and blue is using a yardstick. So what this is called is scale. And all a scale is how big, right? If you're looking at a graph, scale is where your tick marks are. But if we are using the metric system, the meter stick, and the imperial system, the yardstick, one is inches, one is centimeters. We're talking a different language. This is like saying K in English and in Spanish. One means yes, like okay, and one means what. So you're not talking the same language. They're not meaning the same thing. So when we look at that example of I got 39 and I got 15, it seems like one person has to be wrong, but really they're both right. What really happened is that length is 15 inches in inches and it's 39 centimeters. So we have to make sure that when we are giving any type of measurement information, to make sure that we are being objectively truthful, which remember means we want to make sure what our measurements and what we're comparing with each other is as close to objective reality as possible so that we can say it's quote unquote true, to say that thing is 15 inches long. So what I want you to realize from this little exercise is that units are made up. It's completely arbitrary. And what I mean by arbitrary is we have to pick something to compare everything to. So we need to set how long a length is. So in the imperial system, a foot was the length of the king's foot or whatever, but the king's feet were different sizes. So you had to standardize it. And that's where metrics came in. And in science, we tend to use a lot more metrics. In America, we're using the imperial system with inches and feet and pounds versus kilograms and all of that. We'll be digging more into the specifics of the different units and conversions. But really for today, what I want you to think about is that there are base units. There are things that are the smallest objective thing that we can take information from and then derive information from there. When we talk about other units other than these 7, they're called derived units because you have to use these base units to come up with the information for them. We'll come back to this, so don't stress out. So the 7 base units, one of them we just talked about is distance, right? So distance is going to be that distance between 2 points, length, right? The base unit in metric system is going to be meters or centimeters, depending on what we're talking about. Usually I think it's meters. When we're talking about how much of something we have, right, we might weigh it. If you put it on scales, you're going to notice one is heavier than the other. Weight is kind of funky though, because if you go onto the moon, you're going to weigh differently. You're going to weigh less on the moon than you would on Earth. You're still the same amount of you. So we can't use weight, that's a derived unit. What we're going to use is mass. How much stuff are you made of? And we're really going to dig into what mass is in coming lessons. We're going to use a lot of mass during chemistry. What I also want you to realize is we're going to be taking other measurements like temperature. Temperature is not how hot or cold something is. It's weirder than that, and we'll actually play around with that also. The other ones on the bottom here that we're not going to get into right now, this one, number 5, the count and amount of something, it's called a mole. We're going to play with that in chemistry as well. It's very much related to mass, like how much of something, the amount, but instead of being the physical amount, like how much stuff physically is there in a space, the amount in moles is a count, the numbers, but it's a weird thing to think about. So number 7, this is the one I really, really want to talk about today, which is going to be time. Time is a great unit to play this activity with because I think most of us hopefully know your units of time pretty well, right? So the other kind of cool thing about units is you can convert. Like we went from meters to centimeters. We went from yardstick to feet and inches. There are different scales and sizes, and we might want to use a bigger or smaller scale depending on what we're talking about. So you need to be able to convert to go from the small to the big, but you also may need to convert from imperial to metric. So there's times when we're going to want to switch and flip and back and forth. This is a skill you will use in your life a lot. If you hear the radio, if you're in Canada, you're going to have to go from kilometers per hour to miles per hour. All these different units you should be able to convert. The other best thing about this is if you can get a sense and understand this in the store, whenever you look at when you're buying something, it'll say how many pounds or how many dollars per ounce or how many dollars per pound. And they will purposely put it there so it's hard to compare two products because they want you to spend more money on stuff. So if you get good at this conversion, you can save a lot of money. And who doesn't want more money? So back to time. Time, what we're looking for is the base unit of time. So what time is the separation between two events. So where distance is the separation of two objects physically in three-dimensional space, right? Time is a fourth dimension. How much time distance in between events. That's what we're measuring when we measure time. And it's weird when you start to describe what is time or what is length, because that's why it's a base unit. It doesn't make sense because it's the deepest, most basic thing we can talk about. A second is going to be our base unit. A second is 1/24th of 1/60th of 1/60th of a rotation. What does that even mean, right? What we're talking about is the rotation of the Earth. So time is kind of cool because it's based on something physical. How we measure a second is based on a day. So we're going to practice going through these different conversions through time in your worksheet. So click over to that right now, and that I'm going to show you why 1 second is 1/24th of 1/60th of 1/60th. And the worksheet should look like this. So I'll see you there in a moment.